Hi all, let's see the next topic of Unit 2, addressing modes. Coming to the contents, we'll discuss the introduction to addressing modes. Then we move on with the different types of addressing modes available. So coming to addressing mode, so addressing mode is one of the main aspect of an instruction set architecture in most of the CPU designs. So when you refer to the term addressing mode, it refers to the way in which the operand of an instruction is specified. If you look at an instruction format of a specific instruction, it is mainly divided into two fields, opcode and an address part. So opcode specifies the operation that has to be performed by the CPU. And coming to an address part, it specifies the location or the information about the operand on which an operation has to be performed. An address part, if you look at the address part of a particular instruction, the address part may contains the actual operand value, or it might contains a register which holds an operand value, or it might contains an address of a memory location where the operand is stored. So that particular the way in which that particular address part of the instruction has to be considered, whether it is the direct operand is stored in the address part, or the address of the memory location where the operand is stored, or the register. So that is specified, that you can know the information about that based on the addressing modes that you implement. So there are various types of addressing modes that helps to identify the types of operands that are present in an instruction. So generally, if you consider the programs, they are written in a high level language and later they are compiled to a machine language. So they are compiled to generate the machine code or a machine language. So this machine code, it has certain low level instructions, and the low level instructions has opcode and operand parts. So the addressing modes focuses mainly on presenting the operand's address in the instruction. So that is what about an addressing mode is. So why these addressing modes are used? Because addressing modes shows the location of a required object in the computer. So the object here, it can be either an instruction or it can be a data. So the output of an addressing mode, we call it as an effective address. So effective address is nothing but it refers to the exact memory location or exact location in the memory where an operand is actually present, that is required to execute a particular instruction. That is called as an effective address. Next, we'll look into the different types of addressing modes that are available. There are different ways of specifying the location of an operand in an instruction, and there those different ways are called as addressing modes. So there are totally 11 addressing modes available. First one is implied, or it is also called as implicit addressing mode, immediate addressing mode, direct or absolute addressing mode, indirect addressing mode, register direct addressing mode, register indirect addressing mode, relative addressing mode, indexed addressing mode, base register addressing mode, auto increment addressing mode, and auto decrement addressing mode. These are all the different types of addressing modes that are available, which will based on which they specify the location of an operand in the instruction depending upon the type of addressing mode that the CPU implements. So we'll start with the first type of an addressing mode, which is an implied addressing mode, or we also call it as an implicit addressing mode. The reason why we call it as an implicit addressing mode is that the definition of an instruction itself, it specifies the operands implicitly. So within the definition of an instruction itself, it contains the operand value. So if you look at this instruction, in the address part of the instruction itself, it contains the actual data. That is called as an implicit or implied addressing mode. So for example, we have an instruction, say complement accumulator. We have an instruction, right? Complement accumulator, clear accumulator. So all these instructions, Whenever you look at the instruction itself, you can easily understand you want to perform a complement operation, and on what you are going to perform, on the contents of the accumulator. So what the operand here is the accumulator on which you have to perform either a complement operation or a clear operation. So the address part itself, the definition of the instruction itself, it contains the operand on which an operation has to be performed. So this type of an addressing mode is called implied or implicit addressing mode. So next type of an addressing mode is immediate addressing mode. In this mode, the operand is specified in the instruction explicitly. So it is not specified in the definition of the instruction. Explicitly, you need to specify the operand. Instead of address field, operand field is present that contains the operand. Say for example, add 100. So add is your opcode and address part contains 100. So what this particular instruction will do, it will increment the value stored in the accumulator by 100. Whatever is the contents of the accumulator, that will be incremented by 100. And for example, move R20. So it initializes the register R to a constant value 20. So, apart from the opcode, the address part contains a value which is called as an operand field. This particular address part contains an operand on which the particular operation has to be performed. So here the operand is specified explicitly. So this is an immediate addressing mode. So if you look at the opcode address part, so the data is directly stored here. Next type of an addressing mode is a direct addressing mode. So in this addressing mode, the address field of the instruction contains the effective address of the operand. So effective address is nothing but the location where the particular the memory location where the particular operand is stored in the memory. So it contains the address field contains an address which points to the memory location where the particular operand is stored in the memory. So if you look at the instruction format, it contains opcode and A. A is nothing but the address location in the this is the memory, and A is the address location on the memory. If you go to that particular address A in the memory, you will find the actual operand. So the effective address is nothing but A. A is nothing but effective address which contains the address which contains the exact location where the operand is stored in the memory. So here we require only one reference to memory to fetch the operand. You are accessing only memory one time, so only one reference is made to the memory. So it is also called as absolute addressing mode. So next type of an addressing mode is an indirect addressing mode. So in this indirect addressing mode, the address field of the instruction specifies not the memory location. It specifies memory location. It does not. It's in this indirect addressing mode, the address field of an instruction specifies the address of the memory location that contains the effective address of the operand. So if you look at an example here, say for example, if I am taking this particular example, there are two examples here. We'll see this. The opcode contains opcode and address part. So address part contains 100. Previously in direct addressing mode, if you go to this 100 location, this is the actual operand. So the effective address is 100. But in case of indirect addressing mode, if you go to this particular 100th location, you will get the effective address that which is nothing but the address where your actual operand is stored in the memory. So here 200 is the effective address. If you go to that particular 200 location of the memory, you find your actual operand. So this is called indirect addressing mode. This is not the effective address. If you go to this particular location, you can find the effective address. Okay. So similarly here, this example also A. If you go to A location, this is an A location where your effective address is stored. If you access that address, you can access your operand. So here you require two references to the memory. One reference to access your effective address, the other reference in order to access your actual operand. So the control fetches the instruction from the memory and uses its address part to re-access the memory that stores the effective address. So this type of an addressing mode slows down the execution because you require multiple memory accesses in order to find the operand. Next type of an addressing mode is a register addressing mode, or you can also call it as a register direct addressing mode. So in this type of register addressing mode, the operand is contained in a register set or in a register which is present in the register set. So address field of an instruction, it contains the name of a register which contains the operands. So no reference to the memory is required to fetch the operands. So if you look at the instruction, it contains a register. If you go to that particular register which is present in a register set is nothing but is where it contains some set of registers that are available in the computer. Within that, this register is present. If you go to that if you access that particular register in the register set, you can find the actual operand. So in this case, your operand is directly stored in the register. You need not have to access the memory location in order to access your operand. So let us see an example. So the opcode and an address part. So address part specifies a register value. So R is my register, name of my register. So this is the register set which contains set of registers R, R1, R2, R3. So if you access this particular register R in the register set, your operand value will be stored. So you can access this operand, okay, and execute the instruction. So this is called register direct addressing mode. Directly within the register, you can access your operand. You can get your operand. Next type of an addressing mode is a register indirect addressing mode. So in this mode, the address field of an instruction refers to a CPU register that contains the effective address of an operand. So in this case, only one reference to the memory is required to fetch the operand. So if you see an example of register indirect addressing mode, so opcode and this is the register name. So if I access that particular register in the register set, it doesn't contain the actual operand. It contains the effective address or address of the memory location. So say for example, I have 100 here value. If I access the 100th location of my memory, I will get my actual operand. So in the previous register direct addressing mode, the register contains the actual operand. But in this case, the register stores the effective address. Using the effective address, you can access the memory location to get the actual operand. So this is called as a register indirect addressing mode. So if you look here, the instruction contains a register, and if you access a particular register, you will have an effective address. Through the effective address, you can access the memory in order to access the actual operand or a data. So this is a register indirect addressing mode. So we'll see the remaining part of addressing modes in the next lecture. Thank you.